Hi, so now we are going to find out how the simulator works. The Cabo simulator allows you to continue to work on compositions without having the Cabo around. You can still save presets, you can also record data, sensor data, by using an external MIDI controller. So to access the simulator, we go to MIDI OSC routing and open this application. Once here in the MIDI input section, you can see at the bottom the simulator. What you have to do is turn that line on, select the device you're going to use that should be plugged into your computer, select the channel, and the starting controller, continuous controller. What does this mean? This means that I will just select, for this example, I am using the Behringer BCF 2000. So I will turn the line on, select BCF 2000, that shows up. I'm using channel 1 and I am starting on continuous controller number 21. That is all I need to do. So the first 8 from 21 to 29 will be bow controllers. Then 29 and 30 will be RF lock and IR lock, and then the rest will be triggers. So I can open KData and see that I am not connected to a bow right now, but I can start moving some of these faders around. As I said, the first 3 are going to be the first 3 sensors of the bow, which are in this case the accelerometers, and I can see that they're moving when I move them. So I will put them in the middle because that is there. When we calibrate, the middle is the default. And then we have the rest, the other 5 are the other sensors. So we have grip, hair, length, bridge, and tilt. And you can see how they all work. All we had to do was just turn on the simulator in the MIDI OSC routing window and assign the device as well as the channel number and the starting continuous controller number. That light right next to the starting continuous controller indicates that there is MIDI data coming in. Now for the triggers in IR lock and RF lock, we won't see this displayed in KData, but if we go to a modulation line, we can see that they work. So to do this, let's start by selecting a preset. We'll select the clean preset, which has no modulation. I will now open the modulation window and select as bow sources just IR lock, RF lock, and the triggers, just to make sure that they are working. So we go to trigger, X positive, X negative, Y positive, Y negative, Z positive, Z negative, and we will also select IR lock and RF lock. So IR lock and RF lock are the controllers following these 8 controllers, and I have assigned these buttons to be my triggers that continue from 1 through 8. So this should be RF lock, and we can see that by clicking here I am sending it a value of 127, then I click again to disable and it sends a 0. This one should be IR lock, and there it is, we see that it works. The rest then should all be triggers. X positive, X negative, Y positive, Y negative, Z positive, Z negative. And there we go. We can turn them off. We can turn them on. Off, IR, and RF lock. This allows you to have more flexibility when you are working without the bow, because you can use these also as modulation sources. Now that we have verified that these triggers and IR-lock and RF-lock work, because we can't see them displayed in KData, we will go to time graphs in KData. So when we open the time graphs, we get the display, the time display for each of the sensors. And you can see here that they all work. The good thing about time graphs is that you actually have access to this data recorder even when using the simulator. So let's go ahead and record some data. It will give you a countdown, and then you can start moving your faders. It will also record triggers. And let's stop. So we don't have the triggers or the IR-lock and RF-lock displayed, but again we can go to a modulation window to see if indeed it actually recorded. To play back, I am going to turn off the simulator so that it doesn't get conflicting values when played back. I will also open a modulation window and select once again IR-lock, RF-lock, and the triggers to see if they recorded. Now we go to time graphs and play. There we go. We can see that the first gestures are recorded. Now let's see if any of the triggers, and there you go. They're all there. You can also just play back a selection of what you recorded. But not only can I play a selection, I can also loop it. Here we have the triggers. Now there wasn't a lot going on with the other sensors when I was playing with the triggers, but you can see that there was still some information there. Okay, so let's save this file as a simulator test. Notice that I turned the simulator back on so that I can save this. It will not save if the simulator is off. And you can go ahead and quit out of KApps, come back in a few days, and load this file, and all the data should be there. To show that this is true, I am going to record over, and this will be a very short one, just to make sure that we have recorded. And there it is, just a very short one. So now it's a good time to load simulator test. And because the other one that I had recorded, the data that I had recorded was very short, the selection is not the whole file that I have now loaded, so I have to select everything and play. And there I can see that the data is showing up, and there are the triggers. So it does recall, and you can load this file. You can also loop it. So it is important to remember that although you can play the bow from tip to frog and at the same time vary the hair tension as well as your grip pressure, some of these sensors, when excited simultaneously, will give you different results because you're actually playing the bow. You're using the bow as a controller, which is very different to using faders. So we have a KBow model that comes with your KApps applications in your KBow folder. There is a utilities folder, and we have OSC monitor and bow model. So for the KBow model to work, you need to have OSC dump on. And OSC dump is in the OSC output section of the MIDI OSC routing application. And the dump is just a button. It lights up when it is on. And that's how you know that OSC dump is on. And to verify that it is actually outputting OSC data, then you open the OSC monitor and you can see by moving these faders that the data is coming in. There are different values that are coming in. There's also the KBow model. To run the KBow model, you click on this toggle, and you press escape to get the full screen. So I am going to run it, and I can already see a blue bow. And how this works is that I know that this fader controls the grip. So if I increase the grip, then it changes color. And that's how I know that the grip is getting pressure. Then this is hair tension. I know that when I press the bow down, I get more hair tension. This gives you a better idea of what the bow is doing when all of these sensors are sending out data. You have also length, bridge, and tilt. Tilt only works for about the middle third of the bow. So the bow needs to be kind of centered for tilt to work. Now, this is only true for the simulator. For the KBow, you have the tilt works for the whole bow, the whole length of the bow. And we also have the bow twisting, so that you can have an idea of bow motion as it relates to the accelerometers. And this is how the KBow model works with the KBow simulator.